Hey guys, in this video we will be going to take a look how we can add our organization to the running Hyperledger Fabric Network. So for this demonstration we will be going to use the Fabric Samples test network example. And first we will start up by running the test network, and the test network has two organizations with one peer each. And after that we will be going to add another org which is org3, and after that we will be going to invoke some transactions and query the ledger using that newly added organization. So I have already cloned up the fabric samples and I have opened that in my VS Code as well. Here you can see that this is the folder structure of the test network, and here basically this test network provides you one script which is going to automatically add a third organization to your fabric network. But this time we are not going to use this script, and we will be going to follow the manual approach where we will be running each and every command and adding up the org tree to the network. And let's head back to our terminal and let's quickly start the test network. So here I can run this command which is network up, this command, and if I just hit enter, this is going to create the two organization with one peer, and those peer are going to join this channel as well, which is my channel in our case. Okay, so the network has been created and the channel also has been created, which is my channel, and the peers have joined the channel as well. Now let's quickly start the chain code as well. Let's deploy the chain code. So the command for deploying of the chain code is this one, which is right here. This command is basically going to deploy the chain code, and we are going to deploy this asset transfer chain code with the Golang version. Okay, so the chain code has been deployed as well, and we can just quickly try to invoke some transactions as well. So now let's quickly set up the environment variable as well. And now we can just try invoking the chain code as well, which is this command. And basically this time, and basically we are going to create an asset into the ledger with ID as 501. So let's hit enter, and the transaction was successful. We can see that the response here as well. And now let's try to query the chain code as well. So the command is clear chain code query, and if I just pass asset ID as 501, which is the same asset ID that I used earlier when I was invoking of the transaction. So we should see some response against this, and we can see the details here that were stored onto the ledger. So our peers and chain code both are running perfectly. Now we can start adding up the new organization. So in order to add a new organization to the Fabric network, we first need the crypto materials for that organization. So let's quickly use the script that is provided by the Fabric samples in order to generate the crypto material for this org3. So for this, if I just go to this folder, which is add org3 here, and in the VS Code as well, here if we go to this folder, here we have one script which is addorg.sh, and basically in using this script we can generate up the certificates. So I'm going to use this script in order to generate up the certificates. And now let's generate up the certificate. So this is the command which is used for generating of the certificate, and basically this command is going to create a CA container, CA for org3, and then we are going to issue certificate against that CA. So certificate are generated, and let me just clear up this. And now the next step is to generate the org3 JSON file that basically contains the information that are present inside this config.tx that we need in order to update the channel configuration. So let me first export up the environment variable. Basically this environment variable is pointing to our config.tx file that is present inside this current directory, inside this add org3. And if I have to show you this file as well, so this is that file which is config.tx.yaml, and this is the configuration for org3. And now next thing, we will be going to use this file to generate up the JSON file for the org3. So let me put up the command for that here as well. And here we can see that one file should have been created in this location, we should see one file with name org3.json, and basically this file contains the information that is present inside this config.txt.yml. We can verify this as well. So if I go to this folder, which is organization, and then if I go to peer organization, and if I go to this folder, which is org3.example.com, here we should see this file, which is org3.json, and basically this file is representation of what we have inside this config.txt, but in the JSON format. And basically this file also contains the certificate as well. So if you see here, we have the certificate for the admin, and these certificates are in the base 64 encoded form. So if you want to see the content, you can just simply decode the this base 64 string, and then you can use OpenSL or any other tool just to see the content of the certificate. So now the next step is to start up the Docker container for this peer0 of org3. So let's run that command. So this is the command which is going to start up the peer0 org3 container, and here we got some error. And the error is that if we go to this Docker file that we are referring in this command, so this is the Docker file that is present inside this Docker folder. This is that for Docker file, which is docker-compose-org3.yml, and here we have one environment variable, this one. So we have to provide the value for this environment variable. So let me just quickly provide the value for this as well. Here I can provide the value, and I can save the file. And now let me just clear up this first, and now if I try to run this command again, which is docker compose up command, this time so this time our peer container is creating, and it got created as well. So now our peer container is also up, and now we can do the channel update process. So for that, we first need to get the config block for that channel. So the command to fetch the config block is this thing. So here, this is the command, which is peer channel fetch, and here we are passing up the config, which means that we want to get the config block. And after that, we are storing up that output to this file, which is present inside, which is going to be stored inside this folder, which is channel artifact / config block.pb, and then we are giving up the order endpoint and the channel name and the TLS certs as well. So let's hit enter. Okay, what we have to do is first we have to get out of this directory. So now we have to set up the environment variable as well. So these are the environment variables. And now let me just clear up this, and let's run the peer channel fetch command. This is the command. Let's hit enter. So here we can see that we got the config block, which is block number 2. And if I go to VS Code, just to showcase you that that file, so that is present inside this folder, which is channel artifact, and here you can see that the file name is config_block.pb, and we are going to decode this pb file, which is the protobuf format, into the JSON format, and then we are going to apply some modification to the JSON, and then we are going to submit the transaction. So in order to convert the protobuf files into the JSON format, we are going to use the config.txlater tool. So let's put the command here. So this is the command which is going to basically decode that protobuf format into the JSON format. Let's hit enter. And here we can see that the output is stored in this location, which is this file, config_block.json. So let's see this file as well. So this is that file, and basically this file contains the channel configuration, like all the details related to the channel. You can see a bunch of details here, but the most important thing that I want to show you here is that if I just shrink this part, so here you can see that inside this channel group we have groups, then application channel, and then groups. And here right now we have only two organization added, like the details we have here for the two organization, which is org1.org1msp and the org2msp, because currently we have only two organizations that are joined to the channel. But once we are done with the updation process, then you should be able to see other the third organization here as well listed here. So now this file contains a lot of information, but we are interested in only some part of this information. Basically, we need this config block section, this section only. So we are going to use the JQ tool in order to get this block, and then we are going to store this in some other file, and then we are going to manipulate this file. So I'm going to put the command here, and basically this is the syntax that we use with the JQ in order to get the particular tag of the JSON element. So here we are trying to trim the JSON file and get JSON content that is present inside this config block, and we are going to store that inside this file, which is config.json. So let's hit enter, and that file got stored at this location. Let's go to the VS Code, and here you can see that this is that file, and this file has only details, whatever was present inside this config block, those details are here. If you see this file here, so inside this config block we have channel groups and then groups. So same we can see here as well, like channel groups and then all the other details, and the organizations as well. Right now we have only two org that are in that same file as well. So now let's move to the next step. So now we are going to add the JSON file for the org3 that we created in initial steps to this config.json file, so that this config.json has details for the org3 as well. So this is the syntax, and let's hit enter. And as a result of this command, a new JSON file is created at this location with name modified config.json. If we go to the VS Code, let me close these as well. This is that file modified config.json, and if I just have to shrink this, so this time you can see that we have org3 as well here, and now we have all the three organization. Now we are going to perform the next step, which is to compute the delta, and then we are going to submit the transaction. So before calculating up the delta, first we need to convert this modified config JSON into the protobuf format so that the delta can be calculated. So let me put up the command, and this command is going to encode basically this JSON file, this config.json file into this format, which is config.pb. So let's hit enter, and this is the initial file that does not have org3 configuration. And now similarly we are going to encode modified config.json that has the details for the org3 as well into the protobuf format, and then we can calculate the delta as well. So let me clear up this. Let me put up the command here. So basically this command is going to encode this modified config.json, and this modified config JSON file contains the definition for the org3 as well, and the output is stored in this location, which is modified underscore config.pb. Let's hit enter, and let's go to the VS Code as well. And here you can see that we have this modified config.pba and config.pb as well. And now we can use these two files in order to calculate the delta. So let me clear up this, and now we can use this command, which is the config tx later compute update, and then we have to pass the channel ID as well. And here we are passing up the original file, which is not having the configuration for the org3, basically this file, which is config.pb, and the updated one, which has the details for the org3 as well. And then we are storing up the output in this form, in this file, which is org3 update.pb. Let's hit enter, and we can verify that this org3 update.pb is also created, but this file is in the protobuf format, so we have to decode this as well. So let me clear up this, and now we can use this proto decode command using the config tx later tool, and we can decode this protobuf format into the JSON format. So let's hit enter. And why we are doing this step? Because if you remember, in initial steps we basically trimmed some part of that config JSON and took only the required part. But this time, before submitting of the transaction, we have to append that part as well. Basically, that has the header details that we need to attach with our JSON file, and after that we can submit up the transaction. So now we can add those headers detail to this this file, which is org3 update.json. Let's hit enter, and basically if you go to this file now, which is org3 update JSON, here you can see that we have some other details as well. And the important thing that I wanted to show you is this thing, which is the read set and the write set. So initially we had some data on the read set, like the org1 MSP and the org2 MSP. But if you take a look at the write set, this is the write set. And basically this time the write set has the details for the awk3 as well, but the read set was not having the details for the awk3 because before the transaction awk3 was not the part of this channel, but as a part of this transaction we want to include the awk3 and write it to the channel details. So now our JSON file is complete, and now we can just convert this JSON file back to the protobuf format and quickly can submit up the transaction. So this is the command that is going to encode that JSON file that has all the details now, and it is going to create the output with this name, which is awk3 update in envelope.pb. Let's hit enter. So our file got created as well, which is this one, awk3 underscore update in envelope.pb. This is that file, and now we can sign up the transaction as well. So now we can sign up the transaction using the peers, and we have to sign the transaction from both the peers because the signature policies are in majority. So we can just run this command, and basically this command is going to sign the transaction using the org1, basically peer0 of org1. Let's hit enter, and here we can see that this transaction has been submitted, and now we can submit up the transaction using the peer0 of org2 as well. So in order to submit the transaction from the peer0 of org2, first we have to set the environment variables so that our environment variables are pointing to the peer0 of org2. Let's set up the environment variables, and let me just clear up this. And now we can just run the update command, and basically this command is going to have the signature for the org2 as well. So basically we are going to directly update the channel, and the signature are already present for this peer. So let's hit enter. We can see that the channel update was successful. And now we can change the environment variable back to the peer0 of org3, and then we can join the channel as well. So let's set up those environment variables. Now if I run this command, which is peer channel list, right now you can see that we don't have any channel join, but let's join the channel as well. And before that, let's fetch the block 0 so that our peer can join from the block 0. So let's put up this command, and basically uh, our output is going to stored with this name. This is that file name where our output is going to be stored, and now we can simply run that peer join command to join this channel. So I can simply run this command, which is peer channel join, and here we can see that this peer has also joined the channel, which is peer0 of org3. And if I do peer channel list, this time we should see my channel listed here. Also, if we want to see the number of blocks that are currently this peer have, so we can just get them using this command, which is peer channel get info. And here we can see that all the 8 blocks are synced to this peer as well, which is peer0 of org3, and we successfully added the organization to the my channel. Now, just for the sake of this demonstration, let me set up the chain code as well for this peer, and then we will going to invoke the transaction using this newly added organization. So our chain code is already packaged, and that is present inside this current directory. Here we can see that we have this basic tar.gz, which is the package chain code. So we can directly use them instead of packaging up the chain code again. So I can run this command, which is peer lifecycle chain code install. And basically this command is going to install the chain code in this peer, which is peer0 org3. Okay, so the chain code got installed successfully. Let's query the install chain code. So here we can see that we have one chain code installed in this peer, and this is the package ID, and this is the label name. So now we can just quickly approve the chain code for this this organization as well. So so before that, let's export the chain code ID as well. Let's call it as cc underscore package ID, and the value should be this thing. This should be the value. Let's put it, and now we can simply approve the chain code for this org as well. So this is the command to approve the chain code. let's approve the chain code as well. Yeah, so the chain code also got approved and we got the valid response as well. And let me just clear up this, and we can check for the committed chain code as well. Let me put this command, and we can see that we have one chain code definition that is committed with name as basic on channel my channel. So our chain code is perfectly fine, and we can see approvals as well, like all the three organization has the approval for this chain code. So now let's quickly try to invoke some transaction as well using this peer. So let me just clear up this, and let's put the command. And this time, if you see that here we are passing up the endorsing peers, and since we have to provide the majority of endorsement because the chain code is running on and endorsement policy, and right now we have three organization, so the majority of three is 2, so we have to pass minimum of 2 endorsement in order to invoke the transaction. And you can see that we are using the peer 0 of org2 and the peer 0 of org3 as the endorsing peer. So let's hit enter, and here we can see that our chain code was invoked successfully. And basically we call this function, which is init ledger, and we can query against this function as well. So if I just query this ledger, I can do get assets function. I can simply call this get asset function, which is returning me all the assets that are present inside this ledger. And let me just clear this, and let's run this command again. And let me pipe it to a JQ so that we can see them in a better way. And here we can see all the records. And there was one more record. Yeah, this is the first record that we inserted with IDS 501, this ID. And then we have other records that were created when we invoke the ledger using the init ledger function. So this was pretty much it for this video. Hope you enjoyed this video. If you do enjoy this video, then please give a thumbs up and subscribe to the channel, and I will see you in the next one.